Exploring circles. A circle is the set of all points in a plane that are a given distance from a given point in that plane. The given point is the center of the circle. CP is the radius of a circle. A radius of a circle is a segment that has one endpoint at the center of the circle and the other endpoint on the circle. AB and CD are chords of the circle. A chord of a circle is a segment that has its endpoints on the circle. In this picture, you see that DE is a chord. AB is a diameter. A diameter of a circle is a chord that contains the center of the circle. A diameter is twice as long as a radius, or a radius is half as long as a diameter. The circumference of a circle is the distance around the circle. By definition, the ratio of the circumference of a circle to its diameter is the irrational number called pi. If a circle has a circumference of c units and a radius of r units, then c equals 2 pi r. Angles and arcs. Central angles. A central angle is an angle whose vertex is at the center of a circle. In the picture, AOB makes a central angle. The sum of the measures of the central angles of a circle with no interior points in common is 360. A central angle separates a circle into two arcs. As you see in the drawing, there are minor arcs and major arcs. Arcs are measured by their corresponding central. If angle AOC was measured 110 degrees, then arc AC would also be 110. The measure of a minor arc is always less than 180. The measure of a major arc is greater than 180. If the measure of an arc is 180, it is called a semicircle. The measure of a minor arc is the measure of its central angle. The measure of a major arc is 360 minus the measure of its central angle. The measure of a semicircle is 180. Adjacent arcs are arcs of a circle that have exactly one point in common. AB and BC are adjacent arcs. The measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. That is, if B is a point on arc AC, then the measure of arc AB plus the measure of arc BC equals the measure of arc ABC.
I miss you most on winter mornings.
Here's an example of finding arc length. First, find what part of 360 is represented by a measure of the angle QPR. The angle is 1/3 of the circle, so the length of arc QR is 1/3 of the circumference of circle P. Length of arc QR equals 1/3 times 2 pi r. 1/3 times 2 pi times 9. So PR equals 9. 6 pi, or about 18.8 units, is the length of arc QR. Concentric circles lie in the same plane and have the same center but have different radii. All circles are similar circles, so concentric circles are also similar. Circles that have the same radius are congruent circles. Congruent circles are also similar circles. As with segments and angles, if two arcs of one circle have the same measure, then they are congruent arcs. Congruent arcs also have the same arc length. When a minor arc and a chord share the same endpoints, we call the arc of the chord.
Getting kicked out of school cause she's failing. I'm kinda nervous cause I think I'll invitate me. She's the one, she'll always be there. She took my hand and that made it, I swear. I fell in love with a girl at the rock show. She said
A polygon is an inscribed polygon if each of its vertices lies on a circle.
when she's somewhere.
In a circle, if a diameter is perpendicular to a chord, then it bisects the chord and its arc. In a circle or incongruent circles, two chords are congruent if and only if they are equidistant. Inscribed angles. An inscribed angle is an angle whose vertex is on the circle and whose sides each contain chords of the circle. On this circle, ABC is the intercepted arc.
Check, yes, Juliet, are you with me? Rain is falling down on the sidewalk. I won't go until you come outside.
Tangents. A tangent to a circle is a line in the plane of the circle that intersects the circle in exactly one point. The point of intersection is called the point of tangent.
Lace up your shoes. Here's how we do. Run, baby, run. Don't ever look back. They'll tear us apart if you.
A line or line segment that is tangent to two circles in the same plane is called a common tangent of the two circles. There are two types of common tangents. First, common external tangents do not intersect the segment whose endpoints are the centers of the circles. In the figure above, lines A and C are common external tangents to circle O and circle P. Next, common internal tangents intersect the segment whose endpoints are the centers of the circles. In the figure above, lines J and K are common internal tangents to circle M and circle N. Segment EC and segment ED are examples of two tangent segments. A segment CE such that one endpoint is on a circle, the other is outside the circle, and the line CE is tangent to the circle.
Run, baby, run. Don't ever look back. They'll tear us apart if you give them.
Theorem 910 can be used to solve problems involving circumscribed polygons. A polygon is circumscribed about a circle if each side of the polygon is tangent to the circle. There are two statements that can be equivalent to this. The polygons are circumscribed about the circles, and the circles are inscribed in the polygon. Secants, tangents, and angle measures. A line that intersects a circle in exactly 2 points is called a secant of the circle.
Run, baby, run. Don't ever look back. They'll tear us apart if you give them the chance. Don't sell your heart, don't say we're not meant to be. Run, baby, run. Forever we'll be. Run, baby, run. Don't ever look back. They'll
Special segments in a circle.
you give them the chance. Don't sell your heart, don't say we're not meant to be. Run, baby, run. Forever we'll.
In the figure above, DE and FE are secant segments and contain chords DM and FN. The parts of DE and FE are exterior to the circle are called external secant segments. Segment EM and segment EN are examples of external secant segments.